All right, now away we go here. We're going to solve some trig identities. Now, before we do, let's just look back really quick. And these three identities right here, I'm going to kind of underline them. These three right here are the ones that we're going to really clue in on. Now, we know others, and we're going to tie other things in. These aren't the only things we're going to use. But these are like the new ones that we're going to sort of fold in to our solving strategy here. So that's what we're going to focus on. And so I think maybe it would be helpful if we write them down up here. So we're going to put our first one, our sine squared theta plus cosine squared theta equals 1. That's our kind of fundamental one. And then we have our two that have cotangent and tangent in it. All right, so you go 1 plus cotangent squared theta. And so that one, because the bottom of it is sine, cosecant is also the bottom has sine. So that would be, no, not secant. Sine, that's what are you doing? It's cosecant, right? So equals cosecant squared theta. And then just remember that the other ones go in the other one, right? So 1 plus tangent squared equals secant squared, right? And you can remember that from the fact that cotangent is cosine over sine, and then cosecant is 1 over sine, right? So you can kind of see how those two are related. And then tangent and secant both have cosine in the denominator, right? So it's so you can sort of see how those two are related. So that's why they go with the ones that they go with. All right, so that being said, let's get rocking here. So we have sine of theta times this whole thing, all right? So what we're going to do is we're just going to multiply this out, first of all, just using good old distributive property. And really the only combining you have to recognize is that when you multiply two of the same trig identity together, you get, you just square it, right? Sine squared theta, okay? Now, this is good, and this is looking kind of a little bit like this here, but we got to figure this out first. So sine theta times cosecant theta is going to be sine times 1 over sine, all right, minus sine squared theta. Well, that worked out nice, right? These kind of going to cancel each other out, and then you get your 1 minus sine squared theta. So if we look at this guy right here, all right, sine squared theta plus cosine squared theta equals 1. Well, if I solve for cosine squared and I move this sine squared over to the other side, right, I would get cosine squared theta equals 1 minus sine squared theta. And if you're not exactly sure where I got this from, watch the previous video again. And I do kind of go over this about, I don't know, 4, 5, 6 minutes in or so. So cosine squared theta equals this. So because of that, I can just basically rewrite this. And you always want to write it in simplest forms. Basically, what simplest forms means for these is just as few identities as possible. If you're able to represent this whole thing with just one function, then hey, that's a win. All right, now this one right here, I'm going to be completely honest, kind of threw me off for a minute because I went right away to multiplying it, and I missed the elephant in the room. And the elephant in the room is this can be figured out really easily from this first identity here, right? So if I go 1 minus cosine squared theta, right, that is equal to sine squared theta, right? Because if we have this, right, cosine squared theta equals 1, and I get rid of my cosine squared theta from both sides, I get sine squared theta equals this 1 minus cosine squared theta. And that happens to be what's right here. So what I'm going to do next, okay, I'm going to erase this. So if you have to pause the video and go back to get that down, knock yourself out. So I'm going to go secant of theta times sine of theta times, and now we're going to substitute sine squared theta for this thing right here. Okay, so that's kind of cool because you get rid of this one and you get rid of one of these, and then you have secant of theta times sine of theta. And let's see if we can do something else with this one. Well, secant of theta, if you remember, is 1 over cosine theta. And then sine of theta is already kind of written in our basic building blocks. So what you wind up with when you multiply these together is you wind up with sine of theta over cosine of theta, which is how we now define tangent. So that whole thing simplifies down to tangent theta. All right, so both of these kind of use this, right, in kind of a fun, sort of twisty way, but that's kind of what you're going to see. So as I'd mentioned, I actually, when I originally started solving this before I made the video, I started multiplying this out at first, and I got this big, like, crazy convoluted thing that was like really complicated, and I'm sure I could have seen it through and probably eventually gotten to this, but it was way too much work. When you can actually just do the simple thing, take the easy thing that they're giving you and go with that. And so I guess the moral of the story is that you may have to try these more than once sometimes before you see the clear and easy path to solving it, or not solving it, but simplifying it. So just putting that out there, because it's good to know that when you're doing something like that, don't think of it as failing, but think of it more as, well, I've kind of eliminated that as a viable possibility for this right now, you know, and unless I have to go back and look at it again. But I've decided I went down that road. That's not where I want to go, so I'm going to go down the other one. So that's part of math, and don't let it discourage you too much, and we'll see you in the next video.